Hi, in this video, contents related to documentation for troubleshooting will be shared. Documentation for troubleshooting allows for systematic analysis and resolution of issues. This not only speeds up the resolution of the current problem, but also helps prevent similar issues from occurring in the future. Documentation examined under headings such as drone identification and flight conditions, problem identification, diagnostic process, solution steps, and key elements in troubleshooting provides a valuable resource for UAV operators and technicians. Documentation reduces repair time, lowers repair costs, and extends the equipment's lifespan. It also improves quality by reducing errors and allows for sharing of best practices. Transferring information through documentation, sharing experiences, and standardization process increase efficiency. Recording information about drone identification and flight conditions is important to flight safety. When specifying the drone identity, include the model, serial number, firmware version, flight dates and times, and the last maintenance date. Environmental conditions should cover weather, flight mode, mission type, and potential electromagnetic interference. This information should be recorded regularly and comprehensively as it serves as reference for post-flight analysis and maintenance processes. For UAV operators and technicians, observing initial symptoms is crucial in the problem identification process. First, determine basic information such as the observed symptoms, when the problem occurred, and at which flight stage it happened. Warning message or error codes displayed on the screen can also provide clues about source of the problem. In the initial assessment stage, visually inspect the drone and for any obvious damage or abnormalities. Then perform systems and function checks and apply necessary basic tests. To analyze the problem more detail, proceed to data collection step. At this stage, examine first logs, error message, parameter settings, video recordings if available, telemetry data, battery status, sensor readings, and previous maintenance history to obtain deeper insights into the root cause of the problem. Diagnostic procedures begin to determining the tests to be performed, the equipment to be used, and the software tools needed. Various parameters are reviewed and the results obtained and recorded. During drone parts tests, carefully note the results according to the tested part, test methods and conditions, and record any out-of-limit values. In the flight log analysis stage, examine parameter trends and system responses, and evaluate performance values and identified anomalies. In error code interpretation, complete the diagnostic process by considering the meaning of the codes, related systems, historical events, and the manufacturer's guidance. For example, to facilitate troubleshooting, DJI has defined troubleshooting through 4 main codes. 5-digit error codes starting with 10 are camera and memory card errors. 5-digit error codes starting with 30 are GPS or IMI errors. 5-digit error codes starting with 40 are gimbal errors, and 6-digit error codes starting with 180 are sensor errors. Over time and with experience, each technician can develop their own classification system to speed up their process. UAV maintenance technicians should document the solution steps in detail if a repair or part replacement has been made for troubleshooting process. It is necessary to record the procedures performed software changes, used configuration updates, and calibrations during this process. It is important to ensure system verification and by adding the tools used, repaired parts, and tests and performance checks performed. In case where parts replacement is required, record all details related to the part to be replaced, including part and serial numbers, manufacturer information, batch numbers, and installation date. During the replacement process, carefully follow the disassembly and assembly steps, calibrate the new part, and finally verify the accuracy of the process with flight tests. Using digital systems and mobile solution instead of paper forms in troubleshooting will make process faster and more efficient. With a cloud-based recording system, data will be accessible from anywhere. Real-time reporting will facilitate decision-making by providing instant information. Using artificial intelligence in automatic documentation and records will increase efficiency. Blockchain technology for records will maximize security. Internet of Things integration will strengthen the connection between devices. Thanks to IoT, drones will be able to instantly transfer the data they collect to cloud systems, allowing real-time analysis of this data. Additionally, augmented reality will make maintenance and repair process more interactive. Predictive analytics will offer proactive solutions by predicting future problems in the advance. In this section, we covered documentation process in UAV troubleshooting. I hope the contents have been helpful. See you in the next content. Goodbye.